Hi everyone, we are back and we are now going to do our practice exam 2 for ENGR 110. So let's go ahead and look at the problem that we want to solve today. Let's kind of split our screen in half if we're able to do that. And let's do that here. Let's zoom in a little bit so that hopefully all can see. So looks like we have a continuous Fourier transfer problem, which is just fine with us. We can do that. Let's set up our Mathematica notebook here, so we can look at it in its full glory. We're zoomed in. Fantastic. So let's go ahead and name our notebook ENGR 110 practice exam 2. And we can go ahead and get started with these problems. So we're looking at an analog signal. We're asked to calculate the first 4 harmonic coefficients. What's the period, lowest frequency, maximum frequency, dominant frequency, and then we're asked for some other problems as well. So let's go ahead and we can actually answer some of these questions right now. So first, is this signal periodic? So we go up, down, up, here, up, flat. We don't get this kind of continue function here, so it does not appear to be periodic to me. So we can go ahead and see, we start at -10, we end at -1, so I could say that my capital T is equal to 9 seconds. I could then, my del F is going to be equal 1 over 9. So that is my fundamental frequency, my lowest frequency. This is a continuous, oops, I don't know why it's, anyways. So I could do del F numerically. I'm going to do a continuous Fourier transform, so we're only looking at first 4 harmonics, so F max is just going to be equal to 4 times del F. So that will be my, again, oops, why isn't it allowing me to do F max? Here. So that is going to be my maximum frequency. Dominant frequency, I'm going to have to figure that one out. So I've already answered many of the questions in part B. So now I can go ahead and I can start to define essentially my function. So I can see that my y1 is just going to be equal, I'm going to have to use find fit. So let's do find, let's do fit, actually we just do fit. Fit, and then I'm going to do, my points are going to be -10, -8, and then I'm going to go from here. I'm going to do -8 and 6, and I'm going to fit this linearly. Fit 1 T. Let's see if we get, let's look at our fit function. So I can do fit data, yeah, I need to do it 1, x. So I'm going to do a linear fit here. Oh, actually, what is happening with my notebook here? So let's see if I can, there we go. This is just getting us a little bit. So I could do 1, t, fit it. So this is going to be my first function here. So y sub 1 is going to be equal to this over that interval, and we'll go ahead and set up those intervals too. So I'm going to do y sub 2 is just equal to 6. Y sub 3 is going to be, again, I'm going to have to find those values. So I start at -6. For my x, I am at -9 here, -9, and then -6, -9, and then I'm at -5, and then I am at -8. Those are my points. There's my value here. Put it in here. Got it. And then I'm going to do my y sub 4 is going to be equal to, again, I could do -5, -8, because that's where we're starting from here. -5, -8, and then I'm going to do -3, 6. Get that function. Let's see, -5, excuse me. -5, -8. I'm going to get -3, oops, not -6, +6. There we go. Catch those little typos there. And then I'm going to do y5 is going to be equal to 6. So I've got my functions. So now I could do my intervals. So let's go ahead and see if we can find some of those values. So let's just say my intervals. Intervals equals. So my first function goes from -10 to -8. Then I go from -8 to -6. Oops. -8 to -6. Then I go from -6 to -5. Then I go from -5 to -3, and then finally go from -3 to -1, and then I got those interval values. So we've got our intervals now, so we can go ahead and start to calculate our harmonic coefficients and figure out our dominant frequency. So we're going to do, that's basically going to be 2 over RT, 2 divided by T, and then I'm going to do, let's set up a function or code. So I'm going to do my Y list, Y1, Y2, Y3, Y4, Y5, and we want to do this times my integrate, or basically, actually we could do this. I'm going to do, because we're going to do basically Y list, oh, let's shift in there, Y list 1, and we're going to do times cosine of 2 times pi times n times t divided by my period here, and we want to integrate this from values of t from, basically I want to look at, I'm going to pull out my intervals. Intervals 1, 1 to -1. So intervals 1, 1 to intervals 1, second value here. And then get that value, and then we get that. So I'm going to do this, I'm going to do a table, and we need to do a table of those values. And then I'm going to go from I, from I goes from 1 to length of my Y list, length of Y list, and then there we go. And then I'm going to do total, so it's going to add all those up. And then I'm good to go. So this will be my A sub n. Let's just suppress the output. My B sub n will be the exact same thing, but I need to figure out my sine instead of cosine. And there we go. So now I can go ahead and plot, so I could just do list plot of, and I want to go for the first 4 harmonics. So I need my A sub n, actually table of A sub n slash dot n goes to I, where we go from basically 0 to 4 or 1 to 4, whichever the values you want here. So that first one's indeterminate, but again, we'll get that value there. And then B sub n will go from here. So we'll do 1 to 1, 1 to 4 here. And then I could do this plot, and I could do transpose of a table of my I times del f, where my goes from 1 to 4. And I want to transpose this with my table of square root of A sub n squared plus B sub n squared, and then slash dot n goes to I, where I goes from 1 to 4. So we could do this, and I could see that my second harmonic is my dominant frequency. So my dominant frequency is 2 times del f, and we can kind of see that in this table here. We can just pull out this value and see the maximum. So there we go. Excellent. So look at the 3 frequency structures below, which match the Fourier series written below. So my first harmonic is A0 over 2. So this could be a possibility. This, no way. Actually, this is not a possibility. Actually, this is a possibility because I need it's my value here will be A0 over 2. Additionally, remember, when we're in the cosine, this is omega. So really, I know that this value of 17, so this needs to be 35 divided by 2, so, or 34, excuse me. So this could be a possible value, but again, this is frequency in hertz. This is omega. So omega is 0.6, so this is not matching up here. So for example, what I'm saying is that my omega value is in that. So omega equals 2 pi f, so 0.6, I need to solve 0.6 equals 2 times pi times f. So my frequency would be this. So that's not what's being shown here. So this doesn't match, this will not match, especially because of A naught over 2. Here, this is not going to work either because, again, this needs to be 34, 34 of a value here. So none of these will work. For each of the graphs, what's the period? So period is going to be 1 over my delta f. I can see here that this looks to be, let's see, how many do we have? Actually, let's zoom in here just a little bit. So 0.1, 0.2, 0.3. Yeah, so 0.3. So if I do 1 divided by 0.3, that's my period for the first one. For the next one here, 1, 2, this is, or actually 2, 4, 6. 1 divided by 0.6. And then here, this is omega. So this is, again, let's zoom in a little bit here. So this is 1, 2, 3, 4, 5. So omega solve 0.3 equals 2 times pi times f. So my f would be this, or my delta f, and then 1 divided by that would be my period. There we go. So that is your solution to problem 1. So next time we will get into problem 2, and before we even get onto that, I am going to quit my kernel. So excellent. We'll see you all on the next video. Thanks. Bye.